And welcome back. And let's go ahead and set up the necessary steps in order to launch an electromagnetic simulation of this rectangular waveguide using HFSS in the Ansys Electronics Desktop, the AEDT Student Version 2021. And we're going to design a 5G millimeter wave band rectangular waveguide, the WR15, and show you some characteristics. So now we need to assign some excitation where the signal will go in and to out of this model geometry, this box. Select the face that is along the x-axis minimum, right mouse click, and select Assign Excitation Port, Wave Port. View our other videos on the different port types that are available inside of HFSS, namely the wave port and lumped port. Now a window for the wave port pops up, and select a port name. Go ahead and rename it as input and enter the number of modes that you want to excite. Let's look at 5 modes. And you could also click on the next tab, keep the defaults, click finish. Now do the same for the other face on the maximum x-axis and call that the output port. 5 modes. And verify that when you've finished, you'll see under the folder in the project manager window, input and output ports. And now let's add a solution setup with the appropriate frequencies that we want to simulate for this model. Right mouse click on analysis in the project manager window and select add solution setup, advanced. Now a pop-up window appears. Let's set it for a single frequency. And the solution frequency is important because the solution frequency is the frequency that HFSS will use to create the mesh. And the 5G millimeter band is very broad and it's dependent on locale and its use model. But like we said, let's just select 30 gigs as the solution frequency. But this can be set to a frequency that is in the operating band of your model. And the maximum number of passes is the maximum number of passes that the HFSS solver will try to adapt and refine the mesh so that that delta S convergence is met. And 0.02 is the default delta S parameter conversion, and that's for magnitude as well as phase. Go to the Options tab and view the options. Lambda refinement is checked. Tells HFSS to include the model material property, the dielectric properties, the permittivity when determining the mesh. Otherwise, the model is all air. Keep the defaults for the adaptive pass and the solution options. For some more complex geometry, you may want to modify these options, but in general, these defaults are good enough. And the same applies to the other tabs. The Advanced tab, the Brush and Cache, Derivatives. Click OK, view them, and then close the dialog box. And a new model dialog box appears. This will allow you to edit the frequency for the solution setup. If you only need a simulation at the one frequency or only want to see one frequency, go ahead and hit cancel. And the default frequency sweep is interpolating, and that means the HFSS solver will select the frequency it will use in the post-processing results. And this is the most efficient process. Do consider that test equipment measurements are done in discrete steps. So if you want to use a discrete simulation sweep so that you have the same exact frequency the measurement setup, select discrete. Click OK to accept the sweep and proceed to save the project. Now we're all set for the simulation. Go to the Simulation tab and select Validate. A pop-up window appears and has green check marks that precedes all of the necessary simulation steps. And it is good practice to check the Validate button before you simulate, especially if you're new to HFSS. Click Analyze All to start the analysis, and you can monitor the progress window, which is down on the bottom of the UI, and also monitor the message window during the analysis. And let's go ahead and see why is the main reason we use an electromagnetic simulation tool. To view the fields that we cannot visibly see: the electric field, the magnetic field, that are contained in this example WR15 waveguide. Application use 5G millimeter. Now, once the simulation is complete, you'll see in the message window a line that says normal completion of the simulation, and this indicates that the simulation was successful. If there were any errors, you will see that in the message window. We had selected to define 5 modes in the waveport setup. And in the Project Manager window, you'll see a list under the Port Field Display tab for the different modes. Click on the different modes on each of the ports and look at the field pattern on that port surface. For each mode, you'll see a different electric field pattern. And that field pattern displays will help you define the port that is defined. And do you want to see what the cutoff frequency of this waveguide is? Plot the imaginary part of the propagation constant gamma. Right mouse click on the results category and select Create Modal Solution, Rectangular Plot, and in that pop-up window dialog box, select Gamma under the category and select all those modes for port 1. And select IM, indicating the imaginary part under the function column, and click on New Report and close. And this is the rectangular plot for the phase constant. And to identify the cutoff frequency of all the modes, right mouse click on the report and select Add Marker. Select the first non-zero point for each of the modes and press Escape and end the selection. The cutoff frequency for all the modes are tabulated as shown. And similarly, you can plot the next part of the propagation constant, which is the attenuation constant, for all the modes. Here is the plot. So let us plot the electric field distribution for the modes excited in this waveguide. Select the object WG_cavity by clicking O on the keyboard and select the cavity object. And right mouse click and select Plot Fields E, Mag E. A window pops up, and under that context field, go to the solution and make sure the sweep is selected in the drop-down menu, and select Mag E under the quantity. Click Done, and you can see a snapshot of the electric field at some frequency. Now, you can also plot the electric field in vector form, or even the magnetic field, either in magnitude or vector form as well. Let's animate that electric field plot. This gives us a better understanding of what's going on in the model. Go to that Project Manager window, right mouse click on that Mag E plot and select Animate. A new window pops up. For now, keep all the defaults and click OK. You can also save this animation by using the Export option. Go ahead and close the animation. And you can hide this field distribution plot by unchecking Plot Visibility as shown. If you want to see the field distribution for different modes, go to the excitation category in the Project Manager window. Right mouse click and select Edit Sources. In that pop-up window, you can see by default there's only one incident mode of the source is excited with 1 watt of power and 0 degree phase. These are editable. You can also select a different mode by changing the magnitude of mode 2 to 1 and resetting the magnitude of mode 1 to 0. Click OK to accept the changes, and the field distribution is updated to mode 2. Similarly, you can view the field distribution of the different modes in the waveguide by varying their magnitude and phase of the required mode. Here's an animation of the electric field distribution for the different modes of this WR15 waveguide. Thank you for watching this video that shows you how to visualize the E or H field inside of a WR15 rectangular waveguide. And to find more information on HFSS or any of the Ansys simulation tools, please go to ansys.com/courses.